So you can see the question. The skin depth of copper at frequency of 3 GHz is 1 micron, that is 10 to the minus 6 meter, 1 micrometer. Okay, at 12 GHz for a non-magnetic conductor whose conductivity is 1 by 9 times of copper, the skin depth would be. Okay, so we know that the skin depth is basically delta is basically 1 by alpha. Okay, so first you need the formula for delta. Now you have to remember this formula, otherwise I will recommend you to remember this particular formula, that is gamma square is basically j omega mu sigma plus j omega epsilon. Okay, you can remember this formula, it is applicable to many places. Okay, so for good conductor we know that the conduction current density is very greater than the displacement current density for good conductor. So what we can write, sigma is basically very greater than omega epsilon. Okay, this is the condition for good conductor. For good dielectric, okay, you can write that sigma is very less than omega epsilon. Okay, so now you can approximate that gamma square is approximately j omega mu sigma. Okay, so what is gamma square? Gamma is under root j omega mu sigma, and you know under root j, what is under root j? It is basically e to the power j pi by 4 to the power half. Okay, so sorry, pi by 2 to the power half. Yes, so it will be e to the power j pi by 4, right? So this is basically 1 by root 2 plus j 1 by root 2, means cos 45 degree plus j sin 45 degree. Okay, okay, so you can write gamma approximately write gamma as under root omega mu sigma by 2 plus j under root omega mu sigma by 2. Okay, now this gamma is basically the propagation constant, and which is equals to alpha plus j beta. Okay, gamma, where alpha is the attenuation constant, beta is the phase constant. Okay, so what you can write, you can write alpha as approximately equals to under root omega mu sigma by 2, and you can write it as 2 pi f mu sigma by 2. So alpha is basically or nearly equals to under root pi f mu sigma. Okay, so what you can write, delta is basically equals to or approximately equals to under root pi f mu sigma meter. Okay, now you can see the delta is proportional to, or delta is inversely proportional to under root f sigma. Okay, so delta is inversely proportional to under root f sigma. Okay, so you can write delta copper under root f copper sigma copper equals to delta of that material and the frequency of operation and your sigma. Okay, now it is given FCU is 3 gigahertz. Okay, and f of that material, f the operating frequency of that material is 12 gigahertz. Okay, and sigma is 1 by 9 times of sigma cu, so you can replace. Okay, another delta cu is 1 micrometer. Okay, so what you can write from this equation, that is 1 micrometer into under root of under root of FCU, how much, 3 gigahertz. Okay, so you can write under root of 3 and under root of sigma cu. Okay, and that is basically delta under root of f is 12 gigahertz, and under root of sigma is 1 by 9 times of sigma cu. Okay, so you can write it as root 3 under root of sigma cu. Okay, and delta, and under root of 12 is basically 2 root 3. Okay, and this is basically 1 by 3 times of sigma cu. So you can cancel this sigma under root sigma cu, so it will be basically, you can cancel root 3 also. So delta is basically your 3 by 2. Okay, and you can write it as 9 by 4. So you can see option D. Okay, option B is basically 9 by 4 microns. So option B is correct. Okay,